Today I'm up in northern Queensland of Australia in Cairns, and I'm walking the red and blue arrow, which some of you will remember I did last time, the red arrow. This time it should be a lot easier because one, I'm not carrying with me a leather motorcycle jacket and a motorcycle helmet, and two, I've just got back from hiking the Mont Blanc Massif in France, Switzerland and Italy. So my legs are a lot stronger. It's pretty hard to train for a 10-hour European mountain hike when you're living in Australia. 6 or 7 hours of climbing up a mountain, then a small descent to a mountain village for the night. So my fitness for that first week was a bit rough, but as my legs strengthened, but as it went on the second week I got a lot stronger. Now some of this track's in a bit of disrepair, so I'll try this way. So today I'm going to talk about mitochondrial science. We're up to now how the mitochondria produce energy by using quantum technology and also physics that are way more sophisticated than today's hydroelectric dams. Then we're going to talk about some new mitochondrial research, particularly as it pertains to mitochondria and nano-plastics. And we're going to talk about new research on mitochondria and Parkinson's disease. And then we'll look at some information on my hypothesis that gold is money has a lot of similarities to the way mitochondria work. And remember, all these videos are on my general hypothesis that one, mitochondrial science is converging science and spirituality. Two, that mitochondria are both transmitters and receivers of information with a cosmic consciousness, which name you can use whatever you like for it. And three, lifestyle and environmental toxins are impairing that communication of our 1 quadrillion mitochondria with this consciousness. Four, that there are solutions to this. And five, let's add that gold is money and mitochondria have a lot of similarities. And remember, none of this is medical or health advice. Make sure you read this disclaimer and also see the full disclaimer at the end of the video. So before I start on the mitochondrial science, just remember that in the past I've said that mitochondria produce 6 things. I'm going to extend that to 7, which is going to put a lot of this new information in context. So in the past we said that mitochondria produce water, produce light as biophotons, produce energy as ATP, produce heat, and produce pollution as carbon dioxide and free radicals. We also then added the 6th one, which was electromagnetic frequencies. And now I'm going to add a 7th, which probably has even more profound implications for my hypotheses than many of the others, and that is they produce vibrations. So remember, there's good scientific evidence now that most of the universe vibrates, and that's the basis of much communication, vibration. And now we know that not only does the universe vibrate, but also so do our 1 quadrillion mitochondria. So I'll add a new reminder about the 7 things that our 1 quadrillion mitochondria now produce that we can use as a reference. Let's next have a look at mitochondrial science. Last week we looked at the scientific theory of where mitochondria came from. The prevailing theory being that it was a union between a methanogen, which is an extremophile living in the muddy bottom of the ocean, with an aerobic parasitic bacteria like a rickettsia. which then went on to provide energy for every living multicellular organism, animals, fungi, and plants, because it internalized energy production to the mitochondria. So let's now have a closer look at how mitochondria create that energy. Food is broken down into carbon, oxygen, and hydrogen. The carbon eventually joins with oxygen and is eliminated as carbon dioxide. Hydrogen atoms enter the mitochondria and are split into negatively charged electrons and positively charged protons, both of which have very different roles. Firstly, the electrons. They are passed down the inner mitochondrial membrane along the respiratory proteins like a rugby ball being passed down a back line. Think of the breakdown of food as being like the forward pack in a scrum, ultimately delivering the ball as electrons to the halfback. The halfback gets it first and passes it down the back line. Now that's very important to remember when we come to later videos, because if the halfback is getting a new ball faster than they can pass, all kinds of trouble starts happening with the halfback juggling too many balls and spilling the balls, which will be very, very relevant later on. But for now, the halfback is coping and passing the ball down the back line, assisted by quantum physics of quantum entanglement and quantum tunneling. So the inner mitochondrial membrane is essentially acting as an electrical wire. Finally, the electrons pass from cytochrome C to oxygen, which is why oxygen is known as the final electron acceptor. And here, the oxygen combines with hydrogen to form water, which is how mitochondria are known to make their own water. Plus, remember that electrons enter the electron chain through complex 1 and 2, carried by NADH. Again, that will become very relevant to when we come back and discuss the problems with the halfback dropping too many balls. So electrons enter the electron chain through complex 1 and 2, carried by NADH, and are then carried on to complex 3 by coenzyme Q10. Cytochrome C carries the electrons from respiratory protein 3 to respiratory protein 4. Not only does this process use quantum physics, it also uses complex engineering by altering the folding of the inner mitochondrial membrane, known as cristae, to change the spaces between the respiratory proteins. The energy created by this process then has to be stored so it can be used when needed. We can't rely on energy being available on tap. So energy is stored as ATP, known as adenosine triphosphate, and can be stored for hours. Every molecule of glucose from food produces 36 ATP by aerobic, which means using oxygen as we know, metabolism. This is also the way plants make energy, by trapping sunlight to produce ATP via photosynthesis. So all life, every life on Earth produces ATP for energy, either by respiration, fermentation, which means without oxygen, or photosynthesis like plants. The difference is how they break the food down. Eukaryotes, like us, we internalize the food into our cell by phagocytosis. Prokaryotes, like bacteria, they digest the food extracellularly and then absorb the digested food. Now, this is where it gets really interesting, because living systems like balance and homeostasis. So there should be a 50-50 ratio of ADP to ATP inside a cell. They should be in balance, 50-50. But it's more like 90 ATP to 10 ADP. Remember, ADP is adenosine diphosphate. It's adenosine with 2 phosphates on it. And then the spinning ATP rotor adds a 3rd phosphate, a 3rd high energy phosphate to store the energy as ATP, adenosine triphosphate. ADP is therefore continually pushed up its gradient to form ATP. 10 ADP getting pushed up its gradient to form ATP, where there's 90% of it in a cell. It's like pumping water up a hill to a dam to produce energy by eventually releasing the water downhill by the dam. But this time, it's not spinning a dam turbine, it's spinning the ATPase rotor to produce the ATP. The next question then becomes, how do we spin them? Now that's a lot of information today, and next video we're going to be talking about that. which is known as chemiosmotic coupling. But it's a lot to deal with in one video. So we're going to do part 2 of this one next week when we go on and talk about chemiosmotic coupling and the proton motive force to explain how every single organism moves protons against their gradient to spin ATPase to make energy. And that, my friends, is where we will get into one of the world's greatest debates, if not the greatest debate, because those inventions, chemiosmotic coupling and the proton motive force, 3 billion years ago by a bacteria and then adopted by eukaryotes with their mitochondria, was so miraculous that either, one, a 3 billion year old invention that happened by chance and that has never been improved on, proves that we have all descended from that original bacteria known as the common ancestor, or it was such a miraculous design 3 billion years ago, good enough to power every life form on the planet, that it had to have been a product of creative design by a cosmic intelligence. So the first study I want to talk about today was about mitochondria and nanoplastics. Remember that microplastics are defined as plastics which are less than 5 millimeters in size, and nanoplastics are microscopic, defined as less than 1 micrometer in size. And this study documented how nanoplastics act as accumulators of other environmental toxins when they're in the environment, particularly bisphenol A, which is used in plastic, and also heavy metals. And so this latest study looked at nanoplastics in mice and found that they damaged the kidneys, as we know, and also damaged mitochondria. And then they looked at the effects of nanoplastics by themselves, bisphenol A by itself, and then a combination of the nanoplastic sponge soaking up other toxins, particularly bisphenol A, and they found that the combined effects of the nanoplastics and the bisphenol A had a dramatically increased effect on damaging the mice kidneys and their mitochondrial function. Now, bisphenol A was originally developed as a hormone replacement treatment for women, but then along came synthetic and bioidentical hormones instead. So bisphenol A, they found, helped harden plastic and make it less brittle. So it was much better suitable for use in things like disposable water bottles, and also used to line cans so the cans don't leak. So exposure to nanoplastics and microplastics in the environment are now huge, particularly because of water bottles and cans and the plastic that we use to wrap food in, because we know that the food accumulates the plastics which are released from the plastic. And so what they found was that the plastics caused damage to kidney cells by both autophagy and apoptosis. Now remember, they're slightly different. Autophagy is basically a physiological mechanism for damaged cells to break down the cell components and then recycle them. So it's kind of more a recycling physiological operation on cells, whereas apoptosis is used as cell suicide, basically, when cells are so damaged that they can't be repaired. But the microplastics and the nanoplastics and the bisphenol A both increased autophagy and apoptosis, which led to loss of kidney cells, which ultimately resulted in increased kidney dysfunction. So that's why I've really ramped up trying to avoid plastics as much as possible, using glass bottles and buying most of my food from farmers markets before it gets wrapped in plastics. Of course, it's impossible to eliminate them all, but if you have a look at some of the videos I made from a few weeks ago, you'll see some research on how we can also increase removal of microplastics and nanoplastics from any drinking water we use. The second study was on mitochondrial dysfunction and Parkinson's disease. Parkinson's disease being the second most common degenerative brain disease in the world, which usually starts off in people well younger than the age of 60. And we know that mitochondrial dysfunction has been a big part of Parkinson's disease, but we haven't known if that was the cause of Parkinson's disease or the result of Parkinson's disease. Now, this study looked at mitochondria and Parkinson's disease and concluded that it's the initiating step of Parkinson's disease rather than the end result. And that's because of accumulation of a protein in the mitochondria called alpha-synuclein. I'm not sure if I'm pronouncing that right. I think it's called alpha-synuclein, which eventually causes the accumulation of Lewy bodies in brain cells, which is ultimately the signature pathology of Parkinson's disease. So, just bears in mind that mitochondria play a much bigger role in the development of and initiation of Parkinson's disease than we thought before. And finally and quickly, I want to talk about the similarity of mitochondrial science with the concept of gold as money, because I was watching a YouTube video the other day by gold expert Alan Hibbard, and he was explaining that energy tends to dissipate over time. This is known as entropy, the dissipation of energy over time as it moves from a state of order to disorder as the energy dissipates. This is known as the second law of thermodynamics. For an example, an ice cube increases its entropy, increases its disorder as it moves from the ordered state of an ice cube to the more disordered state of water. Similarly with a dandelion in the breeze. So wealth is stored energy and must fight entropy. No one wants to see their wealth dissipate into disorder. So wealth must fight the natural process of entropy. That's what mitochondria do as well. They fight entropy by storing energy, frequency and vibration as ATP. And that's what gold does, because gold is money. It decreases entropy. It's decentralized and arduous, and it doesn't decay. Whereas currency is centralized, easy to produce, increases entropy, and therefore follows the second law of thermodynamics. So you can't see it now, but what is behind me between that tree and that tree as the sun goes down in northern New South Wales is Mount Warning, otherwise known as Wollumbin, which is a sacred mountain of the Bundjalung Nation, part of the Wollumbin National Park. So what am I doing up here looking like a giant tomato on my day off? Well, I've been climbing it. It's got a climb to the saddle you can go over, and doing it for a couple of reasons. One is I'm seeing the sunset. It's a stunning sunset out there when it happens, and of course the sunset, the red light, releases, as you guys know, starts the release of melatonin from my pineal gland, which gets dumped into my cerebral spinal fluid, and we've discussed what that does to, one, it helps sleep, but also what that does to the Warburg effect associated with cancer cells. So one, I'm getting this the sunset to release my melatonin while I drip sweat out of my arms. Then I just have to be very careful not to switch off that melatonin production when I get home with the artificial blue light. So I'm very careful about what lighting I use in my house. Second thing I'm doing is sweating, which is why I'm wearing this, what's called a hot suit, which, as you can imagine, makes me sweat a lot when I exercise in the heat. Didn't have a chance to get to a sauna today, so instead I decided to sweat by using my hot suit on a sunset walk. Third reason, the third S for going out tonight in a hot suit, is that releases heat shock proteins, and as we've discussed previously, heat shock proteins repair or destroy damaged proteins in the brain. And because both my parents died of Alzheimer's disease, I'm very proactive about repairing cells in my brain. The other reason I'm up here tonight is that, as some of you guys know, I was recently in France with the Wilderness Medicine Society, where we climbed the Mont Blanc Massif, and my fitness, because I didn't have enough time to train. I actually did some training in Jersey on the way over, which is in the Channel Islands, halfway between the UK and France. And one of the reasons I wanted to go there in particular was the Gerald Durrell Animal Conservation Park is there. And I grew up in New Zealand reading all Gerald Durrell's books, My Family and Other Animals, about his conservation efforts. And Jersey was small enough that I could walk from one side of the island to the other side of the island and back, which was 3 or 4 hours of walking a day, which I was using to try and get myself in mountain climbing fitness. Big difference though between walking for 3 or 4 hours on the flat and climbing up a mountain all day. And for the first week, it felt like somebody took a flamethrower to my ass with particularly sore gluteal muscles from all the uphill climbing. We got up to about 10,000 feet to go over the saddles from France into Switzerland, and then over the next saddle into Italy. So there was a lot of climbing, and after gaining all that fitness, in the second week I was much better, came back pretty quickly, but I'm really determined not to lose that fitness again, which is why I'm doing a lot more hill climbing as part of my fitness regime. And finally, this is all very consistent with my new meditation practice and my hypothesis that I've been working on, which is that research is bringing science and spirituality together. It's converging it, not diverging it, basically through all of the research on mitochondrial science, which act as the mitochondria, 1 quadrillion of them in our body, act as both transmitters and receivers of information. And one of the ways of optimizing that is with meditation. As I discussed in last week's video, meditation's not easy. There's a process to it, and there's a sequence. The sequence of first is shutting off the monkey mind, second is stillness, and then third is the learning phase. And there's a sequence and a practice to that, which is very important to learn. But also, if my mitochondria, my receivers and transmitters, are clogged up with the inner mitochondrial membrane with heavy metals and pesticides and plastics, doesn't matter how much practice, how much technique you have, if your receivers and transmitters are clogged up, which science has absolutely shown that's what damages the inner mitochondrial membrane, then all that effort in my meditation goes to waste. And I've been getting up at 5 o'clock every morning. That's not negotiable anymore. I get up at 5 o'clock in the morning, even if I work an evening shift at work, I'm still getting up at 5 to do my meditation, because it's become so integral to my health regime and my hypothesis that science will eventually make a strong case that everything's not just a random accident, that there is a cosmic intelligence behind all of this. So, all right, that's enough of philosophy for me for the night. I better get home and empty the sweat out of my hot suit, dripping out of my sleeves. As usual, like and subscribe to the video if you got something out of it. This one was a lot of work. It's actually taken place over several different cities in Australia. And remember, don't forget, no matter how much it hurts, how dark it gets, or how far you fall, you are never out of the fight. Don't give up. And as a friend of mine says, which I remind myself every day now, you can't have fear and faith in the same bucket. Peace and love. See you next time. Thanks for watching. Bye. And remember that after nearly 6 years, I remain suspended in nutritional environmental medicine and can only work as an emergency specialist in a public hospital. So none of this is health or medical advice, and certainly does not replace a professional relationship with your own healthcare provider. And just because I go jumping in freezing cold water doesn't mean anybody else should without adequate training in the hormetic principles of contrast theory.